talk about combining outcomes. So we'll be talking about it, and that is going to be done in this section, which we're now doing, and we're going to first study. We'll be studying just compound events. So, what is that? We're going to first go through the definition, and then we'll go through the different situations that we have when we are studying these compound events. Okay. So, what is a compound event? What is a compound event? This is an event. When you say we have compound events, we just mean that we have events that involve combinations of outcomes. So a compound event is an event which involves combinations of outcomes, more than one outcome, and they are being combined. Okay, and like here they're saying two or more individual events. Okay, so you have different outcomes. So we have compound events as events that involve combinations of outcomes from two or more events. Okay, so we have more than one event. That is why we are calling them compound events. Okay, and these combinations of outcomes can be represented using set operations. So we are going to be combining the outcome of an event to the outcome of another event, and then we say we have compound events. When we are combining these outcomes, we will be using words that convert these combinations into set operations. Okay, that is what we're going to be seeing. We're going to be saying how we convert a certain word into a mathematical operation, because we'll be having two words. One is and, the other one is or, and these quickly change to set operations. So we are combining outcomes. Remember, in compound events, all we are doing is we are combining outcomes. That's the key thing there. Okay, these are events that involve combinations of outcomes, okay, from two or more events. Now, remember we said that the combinations can be represented by operations, or they can be represented using set operations or using operations. And operations we just mean maths, okay, a mathematical way to describe a relationship. So we can represent these combinations using maths, okay? And the operations are, number one, that we're going to be using for our combinations is number one, intersection. And intersection is called the AND operation. So we can say the intersection or the AND operation, okay? And this is used when both events A and B happen. So when we say A intersection B, it's like we are saying A and B, which means that both A and both B have happened. Now that operation, when we are converting it when we are converting it using this set operation into mathematical terms, what you must know about it is we are going to be using the multiplication rule, which would then just say that probability of A intersection B, or A and B, this is just going to be the probability of A times the probability of B, given that A has happened. This is just going to be the general form of our multiplication rule, which is what we use when we are dealing with the AND operation. We use this is going to be the multiplication rule, the general form, and we'll see how to then work with this multiplication rule depending on the different situations which we may have from these compound events. But generally speaking, here is our multiplication rule, which comes from the AND operation, which is that PA intersection B, or PA, remember it's called the intersection or the AND operation. It says the PA intersection B or the PA and B, where we're saying both A and B have happened. How we get the probability of that is we'll be saying it'll be the probability of A times the probability of B, given that A has already happened. Now this is going to be conditional probability, which you may learn about. Now to say how do you get this probability of B given that A has happened? Okay, we'll be saying it's the probability of B given that the event A has already occurred. We'll talk about it later. Now let's see the other one, the union or the OR operator. Okay, the union or the OR operator. So it's like the keyword now will be OR. Here the keyword was AND, and it's that gave us the intersection or the AND operator. When we are having an AND in our words, when we have both events A and B happening. Now here, what about the union operator? The union operator, it is now A union B. We'll be saying at least one of the events happen. In other words, event then we have either A or B or both. Okay, that is when we have A union B. It's like we'll be saying that either A or B or both have occurred. So this is now going to be we now say that the probability of A union B is like to say A or B. This is just going to be the probability that either A has happened or B has happened or both have happened. We saw that for A intersection B, it is that both event A and B have occurred. Now here we are saying either A has happened or B has happened or both of them has happened. What is the probability of that? This is going to be the probability. We use the addition rule, which says the probability of A plus the probability of B, then minus the probability of A intersection B, like this. This is going to be the addition rule, and we are going to use it when we are dealing with the union operator. The union operator, we are going to use the addition rule. This is called the addition rule. You should know it, okay? And we're going to see what changes it. But here is our addition rule. It's like we add the whole of A and then we add the probability of B, but we must subtract the probability of both A and B happening. Okay, that is how we'll get the probability of A union B. Now, why do we do this? Why do we subtract this? It's like you have what is A union B. This is going to be A plus B, then minus A intersection B. Okay, you must know that. You say what? Yes. How do you combine A with B? So it's like when you want to combine A and B, A with B, it's like you would say the whole of A plus the whole of B. But now there's going to be a section which may appear in both of them. Let's have two like this. Let's say this is A, this is B, and let's say A has 7 and has a 5 here, and let's say B has 6 and a 5. Now if we say please combine the whole of A, you'll be saying 7, 5 with the whole of B. You'll be now saying and also 5, 6. Okay. Now can you see that we've put 5 twice? And the reason is because 5 is in both A and B. So that means that we should then be able to remove this one. So we should say minus 5, which is this thing in A and B. Then we will remain with the correct thing. The combination of A with B is just 7, 5, and 6. So that's what happened. You must remove the part which is in both because it would have been added twice. So that is what we are doing. It's minus the probability of A and B because we have added the whole of A, the probability of A plus the probability of B, but we must remove the probability of A and B so that we don't do it double. Then this is going to lead us to our union or the OR operator. That's the addition rule. Here is the multiplication rule, the probability of A times the probability of B, given that A has happened. Okay. Now, let's talk about some words that are going to affect our two rules that when we work with these operations, okay? And these things are going to happen naturally. Don't try to cram this situation. No, it will happen on its own. Now, first thing, let's just go through the definitions of these events, and then we'll see how they affect it. So we start with the first event, which is called when we have two independent events. So we'll be saying now, remember this is going to be an example of compound events. We are still dealing with compound events, which is two events, which is an event that produces two outcomes. We have more than one outcome. Okay, so that is coming from two or more separate events or individual events, and this is leading us to have more than one outcome. So now we are saying, when do we say we have two independent events? When do we say we have independent events? We'll be having two events that where the occurrence of one does not affect the probability of the other. Okay, so the occurrence of one of the event does not affect the probability of the other. Then this is going to be what we say we have when we have two independent events. For example, flipping a coin and then rolling a dice. So flipping your coin or whatever does not affect the probability that you're going to have on rolling a dice. So when you roll a dice, when you say what is the probability of getting a 1 or a 2, whatever, that probability is never going to be affected by the fact that you have flipped a coin before rolling the dice. So these are separate events. These are independent events. Okay, independent events are two events where the occurrence of one does not affect the probability of the other. So the occurrence of one, whether one has happened or not, it is not going to affect the other event, the probability of the other one. Now, dependent events, it is where you have two events where the occurrence of one directly affects the probability of the other. Okay, now we must say a typical example of independent events where the occurrence of one does not affect the probability of the other is when you pick something and you replace. Okay, or you pick and you just see the color, then you put back. So picking and replacing, we'll be saying now the if the first event is not going to affect the probability of the second. But for a dependent event, a typical example where the occurrence of one is going to affect the probability of the other is when you pick without replacing. Because remember, probability is going to be the number of trials over the total trials. So now when you pick and you don't replace, the total is going to be affected, which means the probability on the second pick is going to have less total than the probability on the first pick. So that's going to change the probability. So here an example is drawing two cards without replacement. These are dependent events. If we are not replacing, these are dependent events. An independent, where we say the occurrence of one does not affect the probability of the other, will be picking with replacing. Okay, remember that. Now let's go to another type. Here are other types of events, and we are having mutually exclusive events. When we say we have two mutually exclusive events, these are just events that cannot occur at the same time. These are events that cannot occur at the same time, which means if one happens, then the other must not happen. If one event happens, the other one must not happen. So is it possible to have two events that are independent and mutually exclusive? For independent, we say the occurrence of one does not affect the probability of the other. But here we are just saying here, if one happens in mutually exclusive, if one happens, then the other cannot happen, which means if one happens, then the probability of the other will be zero. So that means that these events are not independent. If they are mutually exclusive, they are affecting one another. If one event happens, the other one cannot happen. So they are not independent, they affect one another. So the mutually exclusive events are not independent, they are dependent events. Mutually exclusive is a special type of dependent event where if one occurs, then the probability of the second is going to be exactly zero. So mutually exclusive events, we can also call them disjoint events. Okay, they cannot happen together. Okay, it is you'll be having events that cannot occur at the same time. An example is an easy thing. Mutually exclusive events are easy. Like example, getting a head and getting a tail when you spin a coin once. Only once. How do you get both? Either you're going to get a head or a tail. You can't spin a coin. Remember, one side of a coin is head, the other one is tail. So you can't spin once and get both of them. These are mutually exclusive. Only one can happen at a time. So when we are putting such events, we show them like this. This is going to be event A, and then this is going to be event B. They have nothing in common. And this leads us to a very important property of mutually exclusive events. For mutually exclusive, remember this all the time, that A intersection B is equal to an empty set. Remember, we never say probability is equal to an empty set, but we can say that A intersection B, the A intersection B itself, not the probability, but A intersection B has nothing, because they have nothing in common. So of course there is nothing. We can't have, if we say, remember that intersection, it means both events have occurred. Okay, but here we can't have them both. Okay, so that is why A intersection B is nada. Okay, now for non-mutually exclusive, these are events that can occur at the same time. Okay, if one event happens, then the other one can still happen. Okay, they can occur at the same time in the same trial. So for example, we are saying, here's an example: rolling an even number and rolling a number greater than 3 on a dice. Okay, can you both roll an even number and a number greater than 3 together on the same dice? Yes. If you roll a 4, it is going to be an even number and it's going to be greater than 3. If you roll a 6 on a dice, it's going to be an even number and it's going to be greater than 3. So you can both. So that is going to say, we can say that A intersection B, that is for both of these two, this is just going to be a 4 and a 6. It is going to be, they are both even and they are both greater than 6. So that means A intersection B is not equal to an empty set. No. So for non-mutually exclusive, these are events that can occur together at the same time. And when we put them, we show them like this. This is our A and our B. And there's going to be something in A intersection B. So we're going to say the property is that A intersection B is not equal to an empty set. But for mutually exclusive, remember the biggest thing is that A intersection B is equal to an empty set. Now let us see how that affects our set operations. So remember, for intersection, the AND operator, we say that we use the multiplication rule, which says P of probability of A intersection B is just going to be the probability of A times the probability of B given that A has happened. Now, what you must know is this happens when you have dependent events, because if we don't have dependent events, there is no such thing as the probability of B given that A has happened. Because we don't care whether A has happened or not if we have independent events, because B will never be affected by anyone. Remember, independent events, we are saying the probability of the occurrence of one does not affect the probability of the other. So probability of B cannot be affected by A. So we can't say probability of B given that A has happened. This is just going to be the probability of B, because probability of B is going to be the same whether A has happened or not. So we can now say that probability of A intersection B is just going to be probability of A times the probability of B if you have independent events. So you are going to write it naturally. Don't try to cram. Okay, if you're going to have independent events, then you know that you can't say probability of B given that A has happened. No, probability of B is probability of B. Okay, so if you have two events that don't affect each other, then the probability of A intersection B, which they can ask you a lot when you use the word and. Remember, when you use the word and, you're going to use this multiplication rule for the and operator. And if they're independent events, remember, you just say the probability of B. You don't have to say given that A has happened. Now, the last one is, what about if they are mutually exclusive? What is this going to be? The probability is going to be equal to 0. That is for mutually exclusive. Mutually exclusive events cannot happen together, and we said the biggest thing about them to remember is that A intersection B is 0. There is nothing in common. In mutually exclusive events, you can't have them both happen at the same time. So A intersection B is going to be 0. So remember, so this is going to be, since A intersection B is going to be equal to an empty set, that means that the probability of A intersection B is 0, because there is nothing in A intersection B. So the probability of getting that is going to be 0. There we go. Now let's go to the union or the OR operator now. Okay, we can say union or operator. Now, what is it? We can say A union B, generally speaking, the probability of A union B, we said we use the addition rule, which is just going to be the probability of A plus the probability of B. But remember to remove the probability of A intersection B, because it is there twice. Now here, this is going to be for what? This is going to be for non-mutually exclusive. This is very easy. Non-mutually exclusive events. Please, this is something to remember. They can ask you for A intersection B for mutually exclusive. Don't calculate it. For two things that can't happen together, then they say, please find the probability of A intersection B. Don't calculate it like this. You know it's 0. For mutually exclusive, for two events that can't happen together, if they ask for A intersection, watch out. If they ask for the probability of A intersection B and you have two events that can't happen together, don't try to calculate. Don't. Your answer is going to be 0 if two events can't happen together. Now here we have probability of A union B. Generally speaking, is going to be the probability of A plus the probability of B minus the probability of A intersection B. This is going to be for non-mutually exclusive, because for mutually exclusive, we know that this is just 0. We are actually seeing it here because there is no way they can happen together. So we can now say that the probability of A union B can actually be just the probability of A plus the probability of B. This is going to be for mutually exclusive. This is going to be for mutually exclusive, two events that can't happen together, mutually exclusive events, because we know that probability of A intersection B of this is going to be 0 for these type of events. So this is going to be done. We have written everything we need to know about this probability section and some of the calculations which you're going to meet here. This is important, okay? This is important. Now we go on to the next thing. Goodbye for now. See you in the next video.